Welcome to Building Connections, presented by IPEX. Each week, we delve into the world of construction, exploring how key leaders in the space shape the infrastructures of tomorrow. Discover the stories behind the solutions that impact municipal, commercial, and residential projects across North America.
Today on Building Connections, I'm joined by Ardas Sabuncuyan, who's the healthcare practice leader at DBR Engineering Consultants, who's a mechanical engineering firm that's really recognized for designing and implementing complex building systems. So Ardas brings a unique perspective on healthcare design, industry trends, and some of the challenges shaping the future of healthcare in the MEP space. Welcome, Ardas.
Glad to be here, Greg.
So what initially drew you to the healthcare mechanical design, and what keeps you passionate about this work today?
First of all, thanks for inviting me to this podcast, and I'm so glad to be here. To answer your question, I have to go back to my younghood. Those years, my mother was facing a chronic kidney disease and needed to have dialysis services. During that time, I ended up spending most of my times in hospitals. I often accompanied her to hospitals for treatment, and I grew up in Turkey. Growing up in Turkey during 1980s, the healthcare system was quite lacking. In those years, I witnessed many inefficiencies in the hospital systems, and sadly, due to poorly maintained dialysis system, water circulation, I have lost my mother. The younghood experience was very traumatic for me, and that's where I decided to have a goal in front of me, and I have to do everything within my capability to have improvement of healthcare services wherever I am. Years later, I attended college and graduated with a mechanical engineering degree and became building mechanical systems design engineer and eventually multi-United States. It was incredible, exciting to join a company that designs healthcare systems for hospitals. In that moment, I committed myself to learn and implement healthcare design in hospitals so that no one would have endured the struggles my mother faced years ago. Greg, I always try to put myself in the doctors, nurses, patient shoes, and I always try to provide the best possible care for them with providing mechanical, electrical, and plumbing services that does help them to perform better and to heal better. I have 30 years experiences in this field. DBR, which is a premier MEP engineering firm in Texas, with over 270 engineers and designers, gave me the opportunity to lead their healthcare facility design and consulting business and let me implement best healthcare design solution ideas for the clients and mentor young engineers on the field. So that's where I am right now.
Okay, so how would you define healthcare mechanical design, and what makes it different from more general mechanical systems work?
Greg, that's a great question. Healthcare mechanical design refers to the specialized field of engineering focused on creating and optimizing mechanical systems specifically for healthcare application. This includes the design utility services that serves to medical devices, hospital equipment, and systems that support patient care, diagnostics, and treatment processes. Here are a few items that I think it makes healthcare design different from the other type of facility designs. On healthcare mechanical design, hygiene always comes first versus energy-focused traditional design. It requires complete mindset differences. Healthcare mechanical design must comply to strict regulations and standards such as FDA guides, health department codes, life safety, and tens of jurisdictional requirements and regulations to ensure safety and effectiveness, which is often more stringent than those in general mechanical engineering design approaches. Healthcare engineers need to be familiar with all these codes and regulations and need to update themselves periodically as regulations get updated. That makes healthcare design engineers rare and valuable, per my opinion. Also, the mechanical design processes prioritize the needs of patients and healthcare providers, requiring a deep understanding of clinical workflows and user interactions to improve usability and patient outcomes. Without understanding the function of the spaces, functional integrations, healthcare design will not be fully successful. As an example, if an engineer does not understand what processes can be done in trauma rooms, hot labs, or nuke medicine rooms, design solution may not be right solution. Given the critical nature of healthcare, design must incorporate fail-safes, redundancy, and rigorous testing to ensure reliability, as any failure can have life-threatening consequences. Many healthcare devices come into direct contact with human body, necessitating careful consideration of materials and designs that are biocompatible and minimize the risk of infection. Well, Greg, overall, healthcare mechanical design merges engineering principle with an understanding of medical practices to create solutions that directly impact patient care and outcomes.
Can you explain what pre-construction design assist means in the context of healthcare and why it's become such a critical part of a project's success?
Let me try to summarize with my best ability from MEP design perspective. This methodology aims to optimize the planning and implementation of mechanical and electrical systems, ensuring they meet the specific needs of the healthcare environment from programming phase of the project design and project construction completion. Understanding the supply chain issues, material pricing, and delivering one building model to our clientele in a condensed schedule that does not only help for the pricing and also improve efficiency and reduce RFI quantities. Best value for design collaboration efforts come from contractors, owners, vendors during the permit design. From my perspective, some of the key aspects of the design assist are collaboration, such as involves close cooperation between architects, engineers, contractors, and healthcare professionals. This teamwork helps ensure that all perspectives are considered from the outset, leading to more effective design solutions. The second one I will say is the cost estimation aspect. Pulling the contractor in early design phase allows for accurate cost assessment and budgeting. Another important item is value engineering and lean decision methodologies. By examining different design options and materials early in the process, the team can identify cost-effective solutions that not compromise quality or performance, enhancing overall project value. And time to time, this solution can be evaluated through lean processes such as choice by advantage or A3 type studies that all stakeholders can have a voice for decision. Um, System optimization, another good one. Design Assist allows for the evaluation and integration of the latest technologies and practices in mechanical systems, such as HVAC, plumbing, med gas systems, to improve efficiency and compliance with healthcare standards. I will add schedule planning next. Understanding the complexities of healthcare facility design and construction can help in developing realistic schedules, minimizing delays, and ensuring that mechanical and electrical design and installation align with other design and construction trades. Risk management is my personal favorite among the others. Early identification and mitigation of potential risks related to mechanical systems can enhance project success. This includes addressing challenges related to space constraints, system integration, and compliance with healthcare regulation. The last but not least is sustainability consideration. The design team can explore sustainable practices and technologies such as energy efficient systems and materials, which are increasingly important in hospital design to reduce operational cost and environmental impact.
Hey, what strategies do you use to ensure a strong collaboration between the owner, the architects, and the engineers, as well as the contractors, during the early design phases?
Greg, at DBR, we are open all the collaboration ideas during the healthcare design phase for the best value, not only for mechanical system design, but also plumbing, electrical, fire protection, med gas systems. We are very flexible on our approaches. At DBR, we listen our clients first. Then we focus on what strategies do we need to implement to get the best results. First, we need to establish clear communication channels. We need to set up effective communication tools and protocols, such as regular meetings, shared platforms, or project management software to facilitate open dialogue among all parties. We also need to define roles and responsibilities. This helps ensure everyone knows their contributions and how they fit into the overall project. As I said previously, we need to engage stakeholders early. This ensures their insights and concerns are addressed early, leading to more informed decision making. We need to foster a collaborative culture as a team. This can be achieved through team building activities and fostering respectful environment. Setting shared goals is equally important. We need to establish common objectives that align with the project's vision, such as timelines, budget constraints, and quality standards. This helps unify the team's efforts toward achieving those goals. Implementing building information modeling, BIM, is almost necessary every large and complex healthcare project for better collaboration. We need to create a culture where feedback is welcome and iterative design processes are encouraged. This flexibility allows teams to adapt and refine designs based on collective input. Keeping everyone informed promotes accountability, and transparency is another important step. Great. By implementing these strategies, we can foster a collaborative environment that enhances communication, trust, and teamwork among owners, architects, engineers, and contractors, leading to a more successful project outcome.
All right, Ardash, let's talk about some of the constraints that are specific to the healthcare. So if you look at some unique challenges that mechanical engineers face when designing systems specifically for healthcare, what are some of those constraints?
Well, mechanical and electrical engineers encounter several unique challenges when designing systems for healthcare facilities. If I give some examples, starting from regulatory compliances, healthcare facilities must comply with strict regulations and standards, such as those set by FDA, ASHRAE, NFPA, NEC, and local health authorities. I have mentioned before, engineers must ensure designs meet these requirements while maintaining functionality. Safety and reliability is the next one. MEP systems in healthcare, such as HVAC, plumbing, electrical, fire protection, must be designed for high reliability. Any failure can have serious implications for patient safety, requiring redundant systems and fail-safes. Complexity of systems is another challenge in collaborative and data-driven environment. Healthcare facilities often have intricate designs with numerous interconnected systems. Engineers must ensure these systems work harmoniously, which can complicate the design and installation process. Infection control is critical one. Hygiene is number one priority in healthcare design and construction, which makes healthcare facility design and construction unique among other type facility design and construction. Space constraints is another one. It's like a daily challenge for us. Healthcare facilities often have limited space, especially in existing buildings, above the ceiling planums with limited chase spaces, while useful real estate spaces so valuable for facility revenue and function. Engineers must creatively design systems that fit within those constraints while still meeting performance requirements. Acoustics and noise control is equally important for patient care grade. Hospitals need quiet environments for patient recovery. Engineers must design systems to operate quietly and consider sound attenuation to minimize noise disturbances. Let me also talk about the importance of space flexibility and scalability. Healthcare needs can change over time in years, requiring systems that can adapt to new technologies or changes in patient volume. Engineers must design systems with flexibility in mind to accommodate future modifications. Another one is integration with technology. The increasing use of advanced medical technology requires mechanical systems to integrate seamlessly with electronic systems such as patient monitoring and imaging equipment, which adds more complexity to the design. Sustainability is also a growing concern in healthcare design. Engineers must create energy efficient systems that not only reduce operational costs, but also comply with green energy efficiency building standards. We need to listen and listen while user centric design is so important in healthcare. MEP systems must be designed with the end users in mind, including healthcare staff and patients. This requires an understanding of workflows and needs to ensure that system enhance rather than hinder operation. Greg, addressing these challenges requires a collaborative approach, innovative thinking, and a deep understanding of both engineering principles and the unique demands of the healthcare environment.
Okay, so let's talk compliance versus innovation. With strict regulations in place, how do you find space to innovate while you're still trying to meet compliance requirements like, FGA or NFPA?
Great questions, great. Finding space to innovate in healthcare design while adhering to strict compliance requirements involve a careful balance of creativity and regulation. Here are some strategies come to my mind to achieve that. We need to engage all the stakeholders, including regulatory bodies, healthcare providers, engineering teams from the outset. Collaborative discussion can lead to innovative solutions. We need to familiarize ourselves with the specific requirements of healthcare facility construction regulations. A deep understanding of these guidelines can reveal areas where interpretation or flexibility can be applied, allowing for innovative designs within the regulatory framework. We need to focus on user needs. We need to listen to our clients. I'm repeating this frequently because this one is one of the most important items on my list. We need to prioritize the needs of patients and healthcare providers in our design process. Innovative solutions often emerge when the focus is on enhancing user experience, workflow efficiency, and patient care while still complying with regulation. Leverage technologies such as building information modeling and simulation tools to visualize, analyze designs are important. This can help identify innovative solutions that comply with regulations while optimizing functionality and efficiency. We need to utilize state-of-art survey devices for accuracy. At DBR, we have a great team of building surveyors. We use LiDAR imaging technologies for the surveys in the existing healthcare facilities, especially surveying ceiling plenum spaces, very hard while these spaces are very congested, and we need to retrieve as much as accurate data, especially on renovation projects. Sophisticated technologies help to accurate mapping the area and minimize error margin of renovation projects survey and we save survey time. Always, it's a good idea to explore modular and prefab solutions. We need to do during the design, we may need to consider modular construction and prefabricated components that can be assembled on site. These approaches can streamline compliance with building codes and allow for innovative configurations. Team can save time and budget, and in future facility operation may be more efficient. We need to stay updated on change in regulation, best practices, and emerging technologies in healthcare design. And most importantly, we need to keep it simple for easy operation. Building systems are so complex, and we need to understand even so many healthcare facilities utilizes building automation systems. However, operators are still human, and complexity make their life very difficult sometimes. By embracing these strategies, designers can create innovative healthcare solutions that enhance functionality and patient care while still meeting the necessary compliance requirements.
How are sustainability and environmental impacts influencing the healthcare today, particularly when it comes to HVAC systems?
So, great. Energy efficiency is leading this subject. There's a strong emphasis on designing HVAC systems that minimize energy consumption. This includes to use high efficiency equipment like variable speed dryers and advanced control systems that optimize energy use based on occupancy and demand. Renewable energy integration is also important. Many healthcare facilities are incorporating renewable energy sources, such as solar and geothermal systems, thermal ice storage concepts into their HVAC designs. This integration not only reduces reliance on fossil fuels, but also lowers operational costs and carbon emissions. We at DB are open for all these concept ideas with discussing and evaluating with our clients, and we bring years of experiences with life cycle and cost analysis to our clients. Sustainable materials are another good one. The selection of environmentally friendly materials for ductwork, insulation, and other HVAC components is becoming more common. Using low VOC, like volatile organic compound materials, help to improve indoor air quality while supporting sustainability goals. There is also growing recognition of the importance of indoor air quality in healthcare settings. HVAC systems are being designed to provide adequate ventilation, utilize advanced filtration such as HEPA filters, and control humidity to create healthier environments for patients and the staff. Heat recovery systems is trending too. The implementation of heat recovery technologies in HVAC systems allow facilities to reclaim waste heat from exhaust air or other processes. This recovered energy can be reused for heating water or spaces, increasing overall efficiency. Smart building technologies and automation systems are being integrated into HVAC design to monitor and control systems in real time. These systems can adjust settings based on occupancy, time of the day, environmental condition, optimizing energy use while maintaining comfort. Also, sustainable design now considers the resilience of healthcare facilities against climate change and natural disasters. HVAC systems are being designed to adapt to changing environmental conditions, ensuring they remain effective and efficient during extreme weather events. Many clients are looking for life cycle cost analysis. A focus on sustainability often involves evaluating life cycle costs of HVAC systems rather than just initial capital cost. This approach considers long-term operational savings, maintenance costs, and the environmental impact of equipment and materials over their lifespan. By integrating sustainability principles into HVAC design, healthcare facilities can reduce their environmental footprint, improve energy efficiency, enhance indoor air quality, and ultimately create healthier environments for patients and staff. These trends reflect a broader commitment to responsible resource management and the long-term sustainability of healthcare infrastructure, Greg.
What are the most significant trends shaping the future of mechanical engineering?
The future of healthcare mechanical systems is being shaped by several significant trends that aim to enhance efficiency, patient outcomes, and sustainability. Here are some of the most notable trends. It's coming to my mind. There is a growing emphasis on sustainable design practices in healthcare facilities. This includes, as I said, use of energy efficient systems, renewable energy sources, and environmentally friendly materials to reduce the carbon footprints, the integration of smart technologies and Internet of Things into mechanical systems in becoming increasingly common. These technologies enable real-time monitoring, data collection, such things like that. Telemedicine and remote healthcare is giving a different angle to this equation. The rise of telemedicine has influenced the design of healthcare facilities and mechanical systems. Now, facilities are being designed to accommodate telehealth services, including dedicated spaces for virtual consultations and improved infrastructure for high-speed connectivity. The use of modular and prefab components is gaining traction in healthcare construction due to schedule challenges. This approach can reduce construction time, minimize waste, enhance flexibility, allowing for quick adaptations to changing healthcare needs. We need to focus on infection control too. In light of recent global health challenges, there's an increased focus on designing mechanical systems that prioritize infection prevention. This includes advanced HVAC systems with enhanced filtration, UVC light disinfection, and controlled ventilation strategies to minimize airborne pathogens. Mechanical systems are being designed with a greater emphasis on patient comfort and experience. This includes thoughtful HVAC design to provide individualized temperature control, improve acoustics, and the integration of nature through biophilic design principles. Also, the use of big data and analytics in healthcare is influencing the design and operation of mechanical systems. Data can help optimize system performance, predict maintenance needs, and improve overall efficiency, leading to better resource management. Healthcare facilities are increasingly designed to be resilient and adaptable to changing circumstances, such as pandemics or natural disasters. This includes flexible spaces that can be reconfigured quickly and mechanical systems that can handle varying loads and demands. Integration of advanced medical technologies are evolving with light speed too. As healthcare technology continues to evolve, mechanical systems must accommodate advanced medical equipment and technologies. This requires thoughtful planning for power, cooling, and space needs to support cutting-edge healthcare delivery. There is also growing awareness of the importance of indoor air quality in healthcare settings, as I said. Mechanical systems are being designed to improve indoor air quality through better ventilation strategies, filtration systems, humidity controls to create healthier environments for patients and staff. These trends reflect a shift toward more innovative, efficient, and responsive healthcare mechanical systems that prioritize patient care, operational efficiency, and sustainability in ever-evolving healthcare landscape, right?
How would you describe the current state of mentorship in the field?
Let me talk about current state of mentorship. As the complexity of healthcare systems increases, the need for effective mentorship is becoming more pronounced. Experienced professionals are essential for passing on critical knowledge and skills to new engineers. Mentorship often involves collaboration across various disciplines, including mechanical engineering, architecture, and healthcare management. This interdisciplinary approach enriches the learning experience and prepares mentees for the collaborative nature of the field. Mentorship is not just about technical skills, it also focuses on developing soft skills such as communication, teamwork, and problem solving. This holistic approach equips new engineers with the tools they need to succeed in diverse environments. Mentors play a crucial role in helping mentees build professional networks. These connections can lead to internships, job opportunities, and collaboration that are essential for career growth. As technology evolves, mentorship is adapting to include guidance on emerging tools and methodologies. This includes training on software applications, data analytics, smart technologies relevant to healthcare design. Here are my advice for mentors with my years of experiences. Be approachable and supportive. Create an open and welcoming environment where mentees feel comfortable asking questions and seeking guidance. Active listening and empathy can foster a strong mentor-mentee relationship. Encourage critical thinking. Challenge mentees to think critically and develop their problem-solving skills. Encourage them to explore different design approaches and consider the broader implication of their work. Share real-world experiences. Provide insight from your own experiences, including successes and challenges faced in the field. Sharing lessons learned can help mentees navigate their own career paths more effectively. Promote lifelong learning. Encourage mentees to stay curious and committed to continuous learning. Suggest resources such as webinars, conferences, professional organizations that can help them stay updated on industry trends. Foster independence. While guidance is essential, also important to empower mentees to take ownership of their projects and decisions. Encourage them to develop their own ideas and approaches while providing constructive feedback. Set goals together. Work with mentees to establish clear, achievable goals for their professional development. Regularly review these goals and adjust them as needed to keep them motivated and focused. Highlight the value of networking, emphasize the importance of building professional relationships within the industry. Introduce mentees to your network and encourage them to seek out their own connection. Be a role model, demonstrate professionalism, ethical behavior, and commitment to equality in your work. Being a positive role model can inspire mentees to adopt similar values in their careers. Encourage diversity and inclusion. Support diverse perspectives in engineering by mentoring individuals from various backgrounds. Promoting inclusivity and can enhance creativity and innovation in the field. Stay engaged. Maintain ongoing communication with your mentees, even after formal mentorship ends. Continuous support can help them navigate their career progression and foster a lasting professional relationship. By actively engaging in mentorship, experienced professionals can significantly impact development of the next generation of engineers in healthcare mechanical design, helping them thrive in their careers and contribute to the future of the industry. Those are my advices, Greg. I hope they hear and they implement because those are my experiences that I'm seeing every day.
Those sound like great advice. And I think, the last question here is, I'm aware you're an adjunct engineering professor at Southern Methodist University. Just, what guidance you're going to give your engineering students that are entering the world of healthcare design?
Well, that's a wonderful question. For engineering students interested in pursuing career in healthcare MEP design, here are some valuable pieces of guidance that to help them to navigate this specialized field. Emphasizing interdisciplinary learning. Healthcare mechanical design often involves collaboration with various disciplines, including architecture, electrical engineering, healthcare professionals. Take courses and participate in projects that expose you to a different fields and foster a collaborative mindset. Focus on relevant technical skills. Gain proficiency in essential software tools commonly used in healthcare design, such as building information modeling, BIM, AutoCAD, Revit, Naviswork, energy modeling software. Familiarity with these tools will enhance your design capabilities. Learn about regulations and standards. Study the relevant regulations and standards that govern healthcare design, such as those from the Facility Guidelines Institute and the National Fire Protection Association. Understanding these guidelines is crucial for compliance in your design. Develop a strong foundation in thermodynamics and fluid mechanics. These fundamental principles are critical in mechanical system design. A solid understanding of these topics will help you address challenges related to HVAC systems, plumbing, and medical gas systems effectively. Engage in practical experiences. Seek internships or co-op positions in healthcare settings or with firms specialized in healthcare design. Real-world experience will provide you with insights into the design process and the specific challenges faced in the industry. Stay informed on emerging trends. keep up with the advancements in healthcare technology, sustainability practices, and design trends. This knowledge will enable you to contribute innovative solutions to the evolving needs of healthcare facilities. Participate in relevant projects and competitions. Get involved in engineering projects, design competitions, or research initiatives. Focus on healthcare applications. These experiences can enhance your skills and help you to build a portfolio of work that showcases your capabilities. Network with professionals. Attend industry conferences in your city or wherever you are. Workshops and networking events to connect with professionals in the healthcare engineering field. Building relations can lead to mentorship opportunities and job prospects. Cultivate soft skills. Develop strong communication, teamwork, and problem-solving skills. Healthcare mechanical design requires collaboration with diverse teams, and effective communication is essential for conveying design ideas and understanding stakeholders' needs. By focusing on this area, engineering students can prepare themselves for successful careers in healthcare mechanical design, contributing to the development of innovative solutions that improve healthcare environments and patient outcomes. And consider to become a professional engineer with taking fundamental of engineering and then professional engineering exam to be responsible with your concept and design and become a professional engineer within your state, or also you can get more state registration, but I highly recommend whoever is choosing this field first passing the fundamental of engineering exam, then become a professional engineer.
Wow, fantastic advice. And that brings us to the end of the episode. I just want to say thank you very much for joining and sharing with us today the world of healthcare mechanical engineering. Much appreciated.
Thank you for inviting me, and it was a privilege to be part of your show. Good luck with the show too.
Thanks for tuning into this episode of Building Connections. You can find links to all of the resources mentioned in today's episode in the show notes. If you're finding value in our podcast, please take a moment to subscribe and leave us a 5-star review. It really helps us connect with more listeners like you. Don't miss out on future episodes. Keep listening and building connections with us.